Right, welcome to today's stream. And on sheet 16, we're going to miss out a couple of questions. One of them is the Maclaurin's expansion, which actually isn't on the A-level syllabus, so we'll miss out that question. And we'll also miss out the question which is building up to doing integration by substitution. I think for revision purposes, we'll just get stuck in when it starts doing proper integration by substitution questions. So our first question today is proving these two identities. And I'll give you 5 minutes to have a go at these ones. One minute to go. Okay, so to prove the first one, what we're going to do is going to write this cos 2 theta using sine squared, I think, and you're going to use the sine 2 theta, you're going to use 2 sine theta over cos theta and see where we get to. So if I take the left-hand side and I make the top equal to, now cos 2 theta, you've got lots of formulae for this. Cos squared theta minus sine squared theta could be 1. Or you could have, that is 1 minus sine squared, so we could have 1 minus 2 sine squared theta. And that's the one I'm going to use. So we could do 1 minus 1, and we've got minus a minus, we get a plus 2 sine squared theta. And that's, you can see why I chose it now, because then the ones cancel. And then I've got sine 2 theta is 2 sine theta cos theta. So those are going to cancel, and it's going to leave me 2 sine theta times by sine theta, because sine square theta is sine theta times sine theta, over 2 sine theta cos theta. And we can see straight away, hopefully, that the 2's cancel out. And unfortunately, my pen's just switched to rubber. So the 2's cancel out, and the sine theta cancels out to leave a sine theta or a cos theta, which is just equal to tan theta, which is equal to the right-hand side. Now, looking at this one, we're going to try writing, I think, sec 2 theta is 1 over cos 2 theta. I think it's a good idea. So that's equal to 1 over cos 2 theta minus 1 over, so sorry, I should state which side I'm starting with. So the left-hand side is equal to this. And then I've got another 1 over cos 2 theta plus 1. And what I'm going to do is I'm going to try and write this as a single fraction. Okay, so I'm going to get 1 minus cos 2 theta over cos 2 theta. And I'm going to divide it by this one. Now if I divide it by this one's the same as 1 over cos 2, 1 plus cos 2 theta over cos 2 theta. Now if I divide by that, I'm going to turn upside down and multiply. So I'm going to turn it upside down, so I'll get cos 2 theta on the top, and I get 1 plus cos 2 theta on the bottom. And again, we can see we can cancel these two down to leave us just 1 minus cos 2 theta over 1 plus cos 2 theta. And what I'm going to do here is I'm going to use this same formula here that I used before, but for the bottom one, I'm going to use the other version. I'm going to use cos squared minus 1, 2 cos squared minus 1, because then I'm going to get a sine squared over cos squared, and hopefully I'm going to get some tans going on. So we're going to write 1 minus 2 sine squared theta on the top, because cos 2 theta equals 1 minus 2 sine squared theta. And on the bottom, I'm going to have 1 plus 2 cos squared theta minus 1 on the bottom. Sorry, I've just gone off the screen slightly there. Let's just bring that back on and give myself a bit more space to finish off. So I can see that that one's going to cancel with that one's going to cancel with that one. And I've got minus and minus, which gives me a plus, so I get 2 sine squared theta over 2 cos squared theta. And we can see we've got another bit of cancelling to go on, so we can cancel out the 2's there to leave sine theta over sine squared theta over cos squared theta, which is just equal to tan squared theta, which is equivalent to the right hand side. Right, next question. We're jumping straight to question 4 on this sheet. Okay, because the other questions are either off syllabus, or actually I don't think it's beneficial to do them from this sheet order in terms of revision. So we're just going to jump straight into this integration question. Let's see if you can do it in 3 minutes. I think it's a 3-minute question if you're doing it as revision. Right, I'm just going to give an extra minute. They're just struggling to try and finish this off. So another 60 seconds to finish off this question. Okay, so we want to find, we've got the acceleration of the car given by a over root t. We want to show the velocity is this. So we're going to integrate a over root 2t, and you probably want to write this as t to the minus a half dt. And because, sorry, to get the velocity, we integrate acceleration. To get acceleration velocity, we differentiate velocity, just in case you were unaware of that. So we want to integrate this. So we're going to add 1 to the power. That gives me t to the half. And then we're going to divide by the power. So 2 divided by a half is 4. And we have to add on our constant. So therefore, we get 4 square root t plus c. That's for part A. For part B, given the velocity is 5 meters per second, 1 second after passing, find the equation for velocity at time t. So it's asking us to find c. So we know the velocity is 5, 1 second, so t equals 1 second. So 1 second after passing A. So we get 4 times the square root of 1, which is 4. We've got 5, so 5 take away 4 is 1, so c equals 1. Therefore, the velocity will equal 4 root t plus 1. So therefore, when t equals 9, probably didn't need an extra minute to work out this because they'd all got up to b. So we've got v equals 4 root 9 plus 1. So square root of 9 is 3. 3 times 4 is 12. That gives you 13 meters per second. Right, let's have a look at our next question. And we're going to use proof by contradiction to prove there are no integer solutions to this equation. I guess if you get it, it's going to be quite a quick one. I'm still going to give you 5 minutes to have a go at it, though, because proofs can be a bit tricky to spot. Here we go. 1 minute to go. Right, my lot have all long since given up on this question. They did spot that it is the difference of two squares you got to do here. Sorry, I ought to say assume x and y are integers, because we have to assume they're integers to do proof by contradiction. So we're going to assume they are integers, and we've got x minus y times x plus y equals 2. So therefore, if x minus y and x plus y are integers, then we must have integers in the brackets. So therefore, we've got integer factors of 2. Now all our factors of 2 have to be 1 and 2, minus 1 and minus 2, and so on and so on. So they have to be one of those things. So what we're going to do is going to have either either x plus y equals 2 and then x minus y equals 1. So that's a pair of solutions. If we solve these, we're going to add these two equations together. This implies that 2x, add these together, the y's will cancel. 2x will equal 3, so therefore x equals 3 over 2. And that's not an integer. Okay. And then we're going to have a look at some of the others. So let's say x plus y equals 1 and x minus y equals 2. And if we add those two together, you get 2x equals 3 over 2 and x equals, 2x equals 3 and x equals 3 over 2. And again, it's not an integer. And then we could look at x plus y could equal minus 2 and x minus y could equal minus 1. Again, add those together, we'll get 2x is equal to minus 3. So therefore, x equals minus 3 over 2. And again, it's not an integer. And then finally, try to get a bit more space to do this question in. So just finish off a space. So we've got x plus y and x minus y. So x plus y will equal minus 1. X minus y could equal minus 2. And then we've considered all the possibilities. And we combine these two. And we get 2x will equal minus 3 over 2 again. And you get, not x will equal minus 3, and x will equal minus 3 over 2. And that's not an integer. So therefore, we have proved this by contradiction. Okay, so let's move on to our next question. And we've got a nice little logs question going on here. I'll just try and just scroll it so you don't have the logo over the question. And we're going to do this log question. I'm going to give you, let's just give you 5 minutes. We've got plenty of time today because we've got less questions. So off. Go. 1 minute to go. Right, so we're going to have to solve 2 log base 2 of x plus 3 plus log 2 of x minus log 2 of 4x plus 2 equals 1. So first thing I'm going to do is I'm going to get this 2 to come up here as a power. So that gives me log 2 of x plus 3 squared. And then I'm going to add to it this log 2 of x. And when you add logs, you're going to times them. So we're going to get log 2 of x plus 3 squared. And I want to obviously times that by this x. I'm going to put that in there. Then I've got to minus this log. And when I do that, I have to divide this into here. So I'm going to divide by 4x plus 2. So when you subtract 2 logs, you divide the thing you are taking the logarithm of. And then we've got log of something equals something. So we can now undo the log by raising both sides to the power of 2. So this side will be just x plus 3 squared. Because the base is 2, we raise this side as a power of 2. So you get 2 to the power of 1, which is just 2. So we're going to multiply throughout by 4x plus 2. So we x plus 3 squared equals 2 times 4 is 8x, 2 times 2 is 4. I'm going to multiply out this bracket, so I'm going to get x, this is x squared plus 6x plus 9 equals 8x plus 4. And I'm going to get x cubed plus 6x squared. I'm going to take away the 8x to get minus 8x. And then I've got plus a 9. Oh, I forgot about the 9x, sorry. So I've got plus a 9x minus 4 equals 0. And what I get here is I get x cubed plus 6x squared plus x minus 4 equals 0. And that's in the form f of x equals 0. Now I want to explain why this has only one real root. Well, I think the easiest way is to solve this. You can use your calculator to help you find a factor, or you can use the factor theorem to look at factors of this. Anyway, the linear factor of this is x plus 1. When I did put this into my calculator and got my roots out, I got minus 1 as a root, therefore x plus 1 is a factor. And then I realise I can just multiply this out, so I need x times x squared x cubed, 1 times minus 4 to get the minus 4. Now, 1 times x squared means I've got 1x squared, but I need another 5x squared to get 6x squared. So I need a plus 5x times by the x to get 6x squared. And we can just check that. So I get 5 times 1 gives me 5x, minus 4 times x minus 4x, that gives me the plus x. So that's how I factorise that. And then I can put this into the quadratic factor. So this implies x equals minus 1, or x will equal minus 5 plus or minus the square root, and when we work all that out, of 41 over 2. Now, this can't be a solution. And minus 5 minus root 41 over 2 can't be a solution because we've got log 2 of x. You can't see that on the screen. Let's put that on the screen. Because we've got this log 2 of x here in the original equation. And if x is negative, we can't take a logarithm of it. So therefore, this can't have any possible solutions. So therefore, the only one real root we can have to that is that the only real root will be x is equal to minus 5 plus the square root of 41 over 2, as log 2 of anything negative can't be done. Yeah, is undefined. Okay, so that's how we do that question. Right, our last question coming up. Okay, give you, let's see if 5 minutes is enough to do this question. We'll see how we get on. One minute to go. Right, so first of all, what we want to do is show there's a root alpha of f of x equals 0 in this interval. So if we do f of 0.8 and put 0.8 into this function, we get 0.48 out as our answer. And if we do f of 0.9, then we get minus 1.2 out as our answer. And because we have a sign change, there must be a root between 0.8 and 0.9. Okay? If you think about it, your graph, if you between 0.8 and 0.9, so here's 0.8 and here's 0.9. If you go for what we've done, we've gone from a positive to a negative, you must have crossed the axes in between. If it's the other way around, then also that would be indicative of a root. So let's go to B. And we want to show that it may be written in this form here. So we're trying to solve this is equal to 0. So we've got 4 cot x minus 8x plus 3. And what we're going to do is cot can be written as cos over sine. So we got equals 4 cos x over sine x minus 8x plus 3. And what we're going to do here, we're going to divide, we're going to take the x to the other side. So we're going to get 8x will equal 4 cos x over sine x plus 3. Then we're going to divide by 8. So 8 is equal to 4 divided by 8 is a half. So we get cos x over 2 sine x plus 3/8. Now for part C, what we're going to do is we're going to use this iterative process. Xn plus 1 is equal to cos xn over 2 sine xn plus 3/8. So I'm just going to call up my decimals calculator here. If I can get it on screen, let's just grab it, bring it down. It's not behaving itself. Here we go. Right. So we've got our decimals calculator here. And we're going to put in 0.85 as our first value because it's in between 0.8 and 0.9, and put that in. Okay. And we're going to do cos of the answer. And then we're going to divide that by, let's put some brackets, 2 times sine of the answer. And then we're going to add to all of that 3 divided by 8. And there's something not looking right here. Oh, because I'm in degrees and I need to be in radians. Let's put it into radians. There we go. 0.81. So we had x0 as 0.85. We had x1 is equal to 0.814 and so on. Now what I'm just going to do is I'm just going to copy that and press enter. On your calculator, what you can just do, if you've done answer and answer there, you can just press enter, 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 and it'll give you the next line. But I can't do that on my computer, so I'm just going to paste that in there. And it gives me the next answer. And then I can do the same again, and it will give me the next answer. And you can keep doing this on your calculator. And you keep doing it until it seems to be tending to a value. And if we keep going, x tends to 0.831. You can see it's oscillating between these two values, and eventually it will hone in on 0.831. I could just do a couple more just to demonstrate that happening. And you can see it's getting closer. So that's getting smaller, and that one's getting bigger. And eventually, oops, and so on. And eventually, what it will do, it will hone in on 0.831 as our final answer. So there we go. That's all for today. Our next stream will be on Monday next week, where we'll do sheet 17 from the workbook.